Hello, good evening, and welcome to secretary class TN10304. Okay, so in this subject, we will have this kind of assessment. Okay, you will have assignments for 30% and lab session for 30%. Usually, lab session we will only take 4 lab reports from our class, and next is your final semester examination, which is 40%, totaling up to 100% in total. Okay, so in circuit theory, we have electrical circuits, electrical networks, and it is an interconnection of electrical elements linked together in a closed path so that an electric current may continuously flow. So that is what we call current, voltage, wattage, and all of those things. For voltage, our unit value is V, while current is defined as the rate of electrical charge flow past a point, and the unit is in amperes. Okay, so there are two types of current, which is DC, direct current, and AC, alternating current. Okay, for DC, it is a current that remains in constant with time. So we have a graph here, x-axis represent the time and the y-axis represent the current. So in this period of time, the value of current will remain constant in a direct current, while in an alternating current, the graph is the same. We have x-axis with time and the y-axis with current, but it is alternating over time, depends on the frequency of our circuit. Okay, so as you can see here, it goes up and down through positive and negative value alternating in alternating current. Okay, so it is in extreme important that we know the polarity or the sign of the voltage and current we use, which way is the current flowing and where is the potential higher. To keep track of these things, two concepts are used: reference polarities and actual polarities. Okay, as you can see here, the reference polarities for power using passive signs convention. The A represent the absorbing power, while B represent the supplying power. Right? So the direction here, the circuit is the same. We have these 2 points, okay, negative and positive. V is your supply, okay, the supplying voltage. As you can see here, when the current goes through in a counterclockwise direction, it represents the absorbing power. P is power, okay, and it will always be in positive value, while supplying power, when the current is going on a other direction, the clockwise direction, and power here represents in negative value. Actually, this is an equation for power, which is wattage. Okay, we usually see this in previous classes where P is equal to VI or IV. It's the same, where I is the current and V is the voltage. So when you multiply voltage and current together, you get the value for power. Depends on the direction of current you are calculating from. The value of power will be in either positive or negative. Okay, so keep in mind that electric current is always through an element and that electric voltage is always across the element between the 2 points. What this means is that, for example, electric current is the flow of electrical charges usually carried by electrons through a conductor or a circuit element. For example, a resistor, a wire, or a light bulb. So the word through means that the current physically moves inside across the body of the components. So there is a resistor. Electric current goes through the resistor itself. That is electrical current through the element. Okay? While electric voltage, such as when it is across an element or between 2 points, okay, point A and B, like we see just now in power. So voltage is called the potential difference, refer to the difference in electric potential energy between 2 points in the circuit, point A and point B. So the word across means the voltage is measured between two ends of a terminal of a component. For example, a battery has a voltage across its terminals. Okay, a battery has the positive and negative terminals. It's between 2 points, meaning one side has higher potential than the other. Okay, let's imagine for current example. We use water flowing through a pipe as an example. Okay, the current is like the water flowing through the pipe. The water is going through the pipe. That is the current. While the voltage is like the difference between in water pressure at two ends of the pipe. So in a pipe, when water is flowing through, that is the current. But the pressure at the start of the pipe and at the end of the pipe, it has difference in pressure. That is the voltage, if you can imagine. Okay. So when dealing in electrical circuits, you can say current flow through a resistor, wire, or component like we've mentioned just now. And for voltage, you can say voltage is across a resistor, across it. It's between two different points. A resistor, a wire, or component. So that is what this essentially means. Okay. So the instrument we use to calculate all these things are voltmeter is to measure voltage, ammeter is to measure current, multimeter is a device that can do multiple things. It can also measure current, voltage, resistors, and other things. You can see which kind of settings you want to use in a multimeter. So for galvanometer, it's to measure small current, value of current, and thermometer is to measure temperature. And finally, for micrometer, screw gauge is to measure length. This is not that essential in our class. The most important thing is these things: voltmeter, ammeter, multimeter, galvanometer, and thermometer. So in a circuit element, there are two types of element found in electric circuits: passive element and active element. So passive elements is to absorb energy. These resistors, capacitors, inductors, all of these are passive elements. While active elements is supplying energy. When you say supply, you already know that it is the voltage supply or the source of the current. That is the active element. So the most important active elements are voltage and current sources that generally deliver power to the circuit connected to them. There are two kinds of sources, independent and dependent sources. An ideal independent source is an active element that provides a specific voltage or current that is completely independent of other circuits. Okay, so this is a few examples for independent and dependent sources. For A over here, the first one we see, this is an independent voltage source used for constant or time varying voltage, while B is used for constant voltage, DC. We usually see this as a battery. Okay, a battery. So for dependent voltage source, as you can see in figure 1.13, this is a dependent voltage source, and the other one is a dependent current source. An ideal dependent or control sources is an active element which the source quantity is controlled by another voltage current. There are four possible type of dependent sources, namely a voltage control voltage sources, a current control voltage sources, a voltage control current source, and a current control current source. So the name here is would be quite confusing, but essentially it is a the first and the second one is a voltage source that is controlled by voltage. That is the first one. But the second one is a voltage source that is controlled by current. The current is controlling the value of voltage sources over there. Okay. And then for the third and the fourth one, both of these are current sources, but they are controlled by voltage and current. Similar things, but it is a two different sources with two different control factor. Okay. So what is an energy? Energy is the ability or the capacity to do work. The amount of things that going through an electrical current will produce energy. So it is a quantity that can take on many forms. Among them is heat, light, sound, motion of object in mass. Okay, so energy, one of the good example that when used to show energy is a car. Okay, when we are in idle form, the car makes noise. It produces heat on the engine itself. That is energy being used. Okay, but it is not an efficient energy because it is wasted by creating the heat, creating the sound from the engine itself. So that is energy. We can see the energy is being produced. So this is the definition found in most dictionaries, although it is dangerous to use non-technical dictionaries to define technical terms. For example, some dictionary list force and power as synonym for energy, but that is not that acceptable in electrical engineering context. Okay, so we will use this as the basic definition for energy. So joule is the unit energy at the unit for energy, joules, as you can see here, joule or J. This is a Newton meter. In everything that we do in circuit analysis, energy is being conserved. And one of the key concerns in circuit analysis is this device, object or element absorbing energy or delivering energy. All right, that is all for the technical terms in our topic today. We'll go through some other things in chapter 1 in the next video. See you later.